let's just go ahead and start with the presentation. Basically, I would like to first start with a little outline. We're going to do most of it is just live, actually importing and setting up set surveys on basis of real SegWi files that sometimes are a little bit modified by us to show you what kind of problems you might find and what kind of things you really need to check and figure out. So first, what I want to do is to get you into some basic concepts, because that's it really helps understanding what you need to do when you do SegWi loading and setting up of surveys. And then you'll get 3D versus 2D, post versus pre-stack, and revision 1 versus the old SegWi stuff, where there was really no standard to go on except a very physical standard of the file format. Now let's first go to the daily practice. I expect some of you to be, almost professional data loaders, others to be casual, well, sometimes data loaders. But this is basically what we would like to see as data loaders. We would like to get our SegWi files and things with everything on it. What are the inline, cross-line arrangements? That would be very nice, and that would really get us in this kind of state. Really, we can really sit back and watch the tapes and disks loading, and everything is okay. But usually it's more like this. The problem is we have to figure out everything ourselves, and it has to be done fast. And that will get you into a more difficult state of mind. And for that, I would like to give you a little bit of advice, which may be a little bit, only for junior data loaders, but you have to work calmly, to work fast. If you want to have fast results, check, recheck, double check. One error now will get you, into lots of trouble later. So just spend a few extra minutes now to get things done quickly. And especially the unexpected things. Don't just pass them away. Don't say, oh, well, they're important. But I want to go further with the last point is, what's the fundamental information? And to just give you an example, let's look at what a well is. For OpenDetect, a well is actually a track with all kinds of stuff around it. But the track is very important because OpenDetect is fundamentally a 3D, a geometrical type of system. You really need to have everything clearly positioned, and for that you also have to have some kind of identification of everything. With a well, it's quite easy to understand. You have a well name that identifies the well, and for the positions you have an X, Y, and a Z, and maybe a measured depth, which is actually internally the thing that we hook everything up to, but we can also calculate that. The thing is, in some cases you need more. You need depth to time. If you have time surveys, you have to. So basically you need to have this data, and everybody understands, yes, this is needed data. There's no way you can get around it. But sometimes you're lucky and you can just do a little bit less, for example, with the vertical well, and then you get to a user interface like this. You just give a well name, X, Y, maybe start depth, end depth. And if for time surveys, you give some kind of velocity, and then just bang, 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 create those wells. But there is a minimum. Without this, you can't do anything. Well, you have the similar problem with seismic data. In seismic data, things are a little bit worse even because, every trace is more or less like this well. Every trace is a bunch of information. And for different types of data, you need different types of identification, because in 2D, you basically have a linear setup, and next to the name of the line and the group of lines that you want to put it to, which is what we call the line set. So we have a line set consisting of many of these lines, which have a geometry by itself. So what we need is per trace is coordinates, and to identify a trace we need a good trace number, something that actually goes up if we go from here to there, or the other way around, but not something that just goes up and back and forth, because that just doesn't identify the trace as such. It's actually, you could see it like in 3D. In 3D you need an inline and a crossline to identify this trace. So here I've actually plotted an inline and crossline, but the inline and crossline says, yes, this is the trace, I know what it is. And that also has coordinates. The thing is, when you set up the survey, you need both inline crosslines and coordinates, because you need to know the relation between the two. But it is a 3D survey, it is rectangular, so maybe you can actually, let's put it like this, you can actually load SegWi files that have either only inlines and crosslines or only coordinates, because of this connection between the two. We can calculate one from the other, but it has to be done somewhere, this definition, and that is in the survey setup. We also have a pre-stack, which is actually yet another dimension, and this adds basically identification and positioning the same, is the offset, because it's actually a fourth dimension. It's plotted, we plot it perpendicular to an inline or crossline in these 3D viewers, but it is actually somewhere in outer space. So that's basically what you need. You have to think about this. It's important to understand that you really have to provide this. There's no way around it. Not in a system like OpenDetect. Maybe you can do it in all kinds of other packages, but in OpenDetect, you need to know where you are. You need to display everything as it is, as you can see here. And that brings me to the 2D survey. I often get the question, why set up a survey if you're in 2D? I just want to see my traces. Well, sorry, but in 2D we also have, we can't just start somewhere. We have to have some kind of box, which is the reference of where am I in the world. That's basically what are the coordinates, where can I see them. And that basically means that we make some kind of pseudo 3D setup, and so the role is basically to set the viewer box, and it's also for sanity checking, because very often we have to check, is something really like a well coordinate or horizon stuff, or also lines. If it's further than 10 times, let's say in that direction, 1, 2, 3, then we just reject it. It can't be right. But you can see very nicely that all lines can stick out, and it can be done on all sides. You can have on top or above, above or below, or left, right, anywhere it can stick out, as long as it's not ridiculously far away. So that gives us some slack, basically. The survey setup is flexible. There's no need for precision. The thing is, we need to have the boundaries, and we have some kind of granularity, because if at a certain point you might want to convert 2D horizons to 3D horizons, you need to do some gridding, and there need to be boundaries for this gridding. So everything together, the survey setup is still necessary, but it's quite flexible. Now in 3D, things are different. 3D, the survey setup tells me what I can expect and what is the actual relation between inline, crossline, and coordinates, and everything is tied to that. So you have to have these coordinates versus crossline, inline. You have to have the boundaries right, because that's basically what you will see displayed. If you say, well, make a new inline, it will make it as big as your survey setup. Z-sampling is another thing. There are all kinds of things tied to the sample rate and the start time. Well, one remark about if you have 2D and 3D in a mixed survey, which is possible, you can have both 2D and 3D, use the 3D setup, because that's what counts. The 2D is just much less important. So you have to remember, the 3D survey setup has to be 100% okay from the start. We can't have a problem there. Good, so that's the start. So we don't need that anymore. So let's start loading a 3D cube. I'll start up OpenDetect just like you would do to show you that it's not just a fake demo. And basically you just got your SegWi file in. Well, let's remove an old try. And what you need to do is, so maybe you saw it, I push this button and then I say I want to have a new survey. Because I got the SegWi file, I have no idea what the survey is, what the parameters are, what the inlines and crosslines are. So I have to go here. So I'm going to say something like 3D test, because I have no idea what this is. This is only 3D now, so I'm targeting that. And then basically what I could do is say, oh, well, enter below. I know the inline range, so that's 300 to 700, 700, and it's step 2 or something, etc. I can follow that through, and I can also provide 3 inlines and crosslines with corresponding X and Y. That would be okay, and I can press OK, and I have my survey set up. That would be nice in this first scenario where you get all the data up front. There's no problem. But usually this is not the case. So what you need is to scan a SegWi file to see what do I have there. And that means I'm going to select so I've just taken a few SegWi files. I'm now going to open it, and you see the file name is there. It's not multiple files. This is really something that's very old in a way. It's only for pre-stack you can still have multiple files, but for post-stack things are in one file nowadays. Anyway, not a problem. We have to select 3D volume. It's already good, and then we get this block here. I will say more about that later, but the thing here is this is an important thing that you actually. We are going to now examine a few traces. We're going to look what we have in this file. And I'll just keep 100 here just to show you. Now, to go any further, so it's a nice window here with, and you can see that we have some data here. It looks very bad. So let's first give you some background on this. Because if SegWi files were nice and everything would be okay and everything would be revision 1 basically, and everything would be 100% right every time, you wouldn't really have to know a lot about SegWi. But as it's not that way, you have to know a bit about SegWi. What does SegWi do? Now this is a schematic overview of SegWi. SegWi consists of really 2 parts, which are subdivided in different parts. Again, 2 parts. First of all, you have what we call the tape headers, which is from the time that everything was on tapes. Nowadays everything of course is on disks and maybe even on USB sticks. But still, that you have a tape header, which is basically information that goes for the entire rest of the file. And the second part is the actual data in traces. So you can see a trace here. That is one trace, and the next trace is there, etc. What you can also see is that the traces themselves are not just the data part, but also a header per trace, which is also fundamental SegWi theory, I would say. Let's go look at the tape headers. First of all,